Hi there. By the end of this lesson, you should be able to identify multiples and apply divisibility tests. So first off, what is a multiple? Well, a number is a multiple of n if it is the product of a counting number and n. So what do we mean by that? Well, we know what the counting numbers are. They're 1 and 2, 3, 4, and so on. So let's say we choose a number n, say our n is 2. And we know that the product is when we multiply two numbers, so let's multiply these numbers, our number n and our counting number. Well, what is that? 2 times 1 is equal to 2. So by this definition, 2 is the multiple of the number 2 because it is the product of that number 2 and a counting number. Similarly, 2 times 2 is 4. 4 is a multiple of 2. Likewise, 6 is a multiple of 2. 8 is a multiple of 2, and so on and so forth. You can do this for every counting number. And we see that all these numbers, 2, 4, 6, 8, these are multiples of the number 2. We could do the same thing with 3. So 3 and a counting number, say 5, is 15. 3 and a counting number, say 10, is 30. 3 and 25 is 75. So we see that the numbers 15, 30, 75, these are all multiples of the number 3 because they are the product of 3 and a counting number. And you could do this over and over again with every single number and every single counting number. These are just a few examples to demonstrate what a multiple is. So then why do we care what multiples are? Well, then we're able to know what it means by a number is divisible. So if m is a multiple of n, then m is divisible by n. So let's take one of those examples last time. So we said that 75 is a multiple of 3. So because of this reason, since 75 is a multiple of 3, then 75 is divisible by 3. And we know that number is 25. You can do this for any number that you find is a multiple of something you know is divisible by that something. So again, another example, let's say the number 100. We know that 100 is a multiple of 4, so therefore 100 is divisible by 4. And again, you can do this on and on with just about any single number that you can think of. So for this reason, if m is a multiple of n, then m is divisible by n. So nothing too difficult to think about there. So why do we care about this? Well, we're going to have to be able to divide numbers in order to, apply algebra and do algebra throughout this class. And there are also what we call divisibility tests, and these are just simple tests that we use and that we have for certain numbers to decide if, a really large complex number is divisible by some of these simple numbers. So if I give you something large, a very large number, if you use these divisibility tests, you can at least tell me, hey, that really large number is divisible by this smaller number, or you can give me some quick examples. So these divisibility tests, one test is for the number 2, and this divisibility test is if whatever you're trying to divide, this large number, if it ends in 0, 2, 4, 6, or 8, then you automatically know that it's divisible by 2. Our next test is 3. Now the divisibility test here is if the sum of the digits of the number is divisible by 3, then the whole thing is divisible by 3. So an example of that, say the number 18. Well, 1 plus 8, the sum of its digits, is equal to 9, and we know 9 is divisible by 3. Another example of that would be 72. 7 plus 2 is equal to 9, and we know 9 is divisible by 3, so therefore the number 72 is divisible by 3. And that's just a simple test for the number 3. Our next test is with the number 5. This one, like 2, if it ends in 0 or 5, is divisible by 2. So 0, 5, 10, 15, 20, all these numbers are divisible by 5 because they end in 0 or 5. Our next test is the number 6. So this one is, if it is divisible by both 2 and 3, then is divisible by 6. So again, it has to be divisible by both 2 and 3. So once you test 2 and 3, you automatically know if is divisible by 6. And then the last one is the number 10, which this one, like 2 and 5, if it ends in 0, it is divisible by 10. Nothing too difficult there. So let's go through an example of this. So, for example, say I give you the number 5,625. If I said, hey, what is that number divisible by? Right off the top of your head, you might not be able to think of something instantly. But if you go through these tests, then you can give me at least a couple examples or a couple of numbers that it is divisible by. So let's test out each of our divisibility tests on this number. So first one is 2. Does 5,625 end in 0, 2, 4, 6, or 8? Well, it ends in 5, so no. This number is not divisible by 2. What about 3? Well, again, this is the sum of the digits, so 5 plus 6 plus 2 plus 5, that is equal to 18. Now, do we know if 18 is divisible by 3 off the top of our head? Well, we can just do this test one more time. So 1 plus 8 is equal to 9. Well, we know 9 is divisible by 3. Therefore, we know 18 is divisible by 3. Therefore, we know 5,625 is divisible by 3. So, yes, this number is divisible by 3. The next one is 5. Is the last digit of this number 0 or 5? Well, 5,625, yes, it is 5. So, therefore, it is divisible by 5. Is it divisible by 6? Well, again, if it is divisible by both 2 and 3, then it's divisible by 6. We know that it's divisible by 3, but we also know it's not divisible by 2, so therefore it can't be divisible by 6. And the last one, 10, is its last digit 0? Well, our last digit is 5, so therefore we know it's not 0, so it can't be divisible by 10. So by applying these divisibility tests, if I asked you what 5,625 is, you could quickly tell me that it's divisible by both 3 and 5. So I'll give you guys one example to work on your own. Just pause the video after I give the number and apply each of these divisibility tests and then see if it is divisible by any of those 5 numbers. Okay, let's go through this example. So, is it divisible by 2? Well, it ends in 2, so yes it is. Is it divisible by 3? Well, 4 plus 9 plus 6 plus 2 is equal to 21. 2 plus 1 is equal to 3. 3 is divisible by 3, so yes it is divisible by 3. Is it divisible by 5? Well, 2 is not 0 or 5, so no, it's not. Is it divisible by 6? Well, we see that it's divisible by 3, and it's divisible by 2, so therefore 4,962 is divisible by 6. And is it divisible by 10? Well, it ends in 2, which is in 0, so no, it is not divisible by 10. So if you came up that 4,962 is divisible by 2, 3, and 6, nice work.